objectives that we gain from this report are 1. To obtain the frequency of each flavor of the sweets. 2. To determine the experimental probability and the theoretical probability of each flavor of the sweets. 3. To identify the difference between experimental probability and theoretical probability. 4. To apply discrete probability distribution function. And last, to compute mathematical expectation which apply mean.
Significance. This project is carried out with the aim to display that probability plays a big part in our daily routine. Besides, it is an objective invaluable knowledge for students to predict anything by applying probability formulae in real-life events. For an instance, students can learn on how to determine the experimental probability and theoretical probability, identify the differences between experimental probability and theoretical probability, and ways to apply discrete probability distribution function. Based on the experiment in this project, probability is used in order to predict which flavor of 3 different sweets will be the outcome: orange, mango, or guava. The sweets will be randomly chosen without having to look with 30 times of repetition to avoid biased results.
Our group assignment for STA150 is about experiment 3, picking up a sweet. First of all, we should have 3 different flavors sweet, and each sweet also should have a different quantity. The flavors that we have are orange, mango, and guava. For orange, we have 11 quantities, mango has 13 quantities, and for guava, we have 6 quantities. All the total of sweets is 30. For this experiment, one of my group members will pick randomly with closed eyes 30 times. The steps for the experiment are: Step 1. We should buy 3 different flavors with different quantities for each, and all the total is 30. Step 2. Put all the sweets in one box. Step 3. Atifa will close the eyes of Amalia, who will pick up the sweet in the box. Step 4. For the first trial, Amalia pick up one sweet in the box randomly. Step 5. After that, Shifa will look at the result and tell Alia what the result. Step 6. Alia will record the results in the table. Step 7. After that, Shifa will put the candy back in the box. And for the last step, the experiment was performed 30 times.
Based on the experiment, we put 30 pieces of sweet in a box, which is 3 flavor. Orange we put 11, mango we put 13, and guava we put 6. Outcome from the experiment, we know that 8 times we take orange, and 10 times we take mango, and then the last one is guava, we take 12. So all of that equal to 30.
For question B, what is the experimental probability of obtaining each of the flavors, orange, mango, and guava? For this question, we need to count number of times events happen, divide by total number of trials. So we need to use formula probability A equals to N divided by capital N equal to NA divided by NS, which is N is the number of outcomes of the events. For orange, 830 equal to 415. For mango, 1030 equal to 1/3. For guava, 1230 equal to 2/5. And next, for question C, what is the theoretical probability of obtaining each of the flavors, orange, mango, and guava? So for this question, we need to count favorable outcomes divided by possible outcomes. For orange, 1130, mango 1330, and for the guava 630.
So
which
the
is
question D, which is what is the difference between experimental probability of obtaining orange flavor and the theoretical probability of obtaining orange flavor? We will answer this question in percents rounded to the nearest whole percentage. We use the formula which is experimental probability minus theoretical probability, which is 4 over 15 minus 11 over 30 equal to minus 1 over 10. 1 over 10 we multiply with 100% equal to 10%. Okay, now I will explain you about question E. The question E is what is different between experimental probability of obtaining mango's flavor and the theoretical probability of obtaining mango's flavor. We will write answer as a percent rounded to the nearest whole percentage. So we use the formula which is experimental probability minus theoretical probability, which is 1 over 3 minus 13 over 30 equal negative 1 over 10. 1 over 10 we multiply with 100% and it will be equal to 10%. So 10% is for the difference between experimental probability and theoretical probability of obtaining mango flavor.
Next question. What is the difference between experimental probability of obtaining guava's flavor and the theoretical probability of obtaining guava's flavor? In this question, we are going to use the formula experiment probability minus the theoretical probability. As we did the questions earlier, we already know the answer for experiment probability and theoretical probability. So you just have to insert the answer and minus it. Therefore, you get 2 over 5 minus with 1 over 5 equals to 1 over 5. Because the questions want the answer to be in percent rounded, therefore you have to times the answer have to times with 100%. So 1 over 5 times 100% equals to 20%. For next question is what is the experimental probability the selected sweets are not orange? For this question, we are going to use the formula 1 minus x with the experimental probability of orange. This is because 1 is the maximum possible value of the probability of an event. Therefore, you just substitute the answer for experimental probability of orange that we already get. So 1 minus with 4 over 15, then the answer equals to 11 over 15.
Now, let's move to the question H. The question is, the probability distribution function for random variable x be defined as follows. For question A, show that fx is discrete probability distribution function. We use truth table to solve this problem. First, we divide it into two parts, which is for x equal to 0, 1, 2, 3, and 4. We use the formula 0.4 plus x per 20, and for x equal to 5 and 6, we use formula 7.5 minus x per 10. After that, enter each value of x into the formula to get fx, and we plus all the value of fx, and it should be y. For question B, instruct the cumulative distribution function fx. To answer this question, we also use truth table. To find cumulative distribution function fx, we have to add the original fx with all the previous fx and to check whether our answer is right or not. Is a value of cumulative distribution function for last value of x must equal to 1. The last question for H is C. Question C is we should calculate exponent 6x plus 2. First, isolate it until becomes 6 exponent x plus exponent 2. And after this, we should find for exponent x. Exponent x, also called as mean. The formula for exponent x is assumption of x times fx. Substitute all value into the formula and get the answer 77/20. And last, substitute the value of fx into the equation. And the answer is 25.1 or 251/10.
So we can conclude that this project has proven that it is crucial and useful to learn about probability in order to make our daily life better and to avoid disadvantage risks in the future. So that's all from us.